Welcome to the 8th video of our series. Today we focus on the crank, which plays a central role in the mechanism of our engine. It ensures that the up and down movement of the pistons is converted into a smooth rotational motion so the engine runs smoothly. When creating the outer geometry, you will learn, among other things, how to trim contours within a sketch to make precise adjustments. Let's get started right away. We begin with a new sketch on the XZ plane. First, we draw a circle from the origin with a diameter of 30 millimeters. Within this large circle, we then create another circle, also starting from the origin, with a diameter of 8 millimeters. Now we need a third circle, also with a diameter of 8 millimeters, which we place slightly above the origin. For this, we select the coincident constraint and display the origin in the browser. Next, we position the center of this new circle so that it is on the Z-axis and set a vertical distance of 8 millimeters. To do this, we can either click on the centers or the existing circle lines to establish the dependency correctly. Inside the newly created upper circle, we now draw a smaller circle with a diameter of 4 millimeters. With these steps, we have now created a solid basic structure that we can use as a reference in the further course of the model. We now use the line command. For this, we move the mouse pointer to the outer circle until the snap function is activated, and then draw a line at the appropriate angle up to the x-axis. After that, we draw a second line that starts at the upper circle with a diameter of 8 millimeters. We then repeat this process in mirror image on the opposite side of the circle. In the next step, we use the symmetry constraint to align all 4 lines symmetrically to the Z-axis. To do this, we first select the 2 lower lines and then click on the Z-axis. We repeat the same process for the 2 upper lines. Due to the symmetry dependency, the changes are now automatically mirrored on the corresponding partner lines, which significantly simplifies our editing. Next, we give the sketch its crucial shape with the missing constraints and by removing the unnecessary circle segments. We select the option Tangent under Constraints and then click on the line and the upper circle. Now the contour is tangent to the circle. To further refine the position, we use the coincident constraint and place the intersection of the 2 lines exactly on the x-axis. Dimension the angles of the upper lines to 29 degrees. On one side, you can dimension the angle between the upper and lower contour line at 129.8 degrees. The 2 lines on the other side should automatically adjust with our symmetry dependency. It's time to tidy up. Switch to the Trim command in the Modify menu and remove everything that doesn't belong to the final component. Start with the outer arc and work step by step until the upper circle with a diameter of 8 millimeters is processed. If an error message appears because dependencies or dimensions disappear, don't worry, that's easy to fix. Just check the sketch and make sure that the relevant connections are maintained. With this step, the foundation for our crank is created. Now we give the component its 3-dimensionality, perform an extrusion and select the previously created sketch as the profile. Extrude the body by 6 millimeters to create a solid base for the following steps. Next, we create a new sketch directly on the surface of the extruded body. Draw a circle starting from the origin with a diameter of 11 millimeters. Perform another extrusion with a height of 0.5 millimeters to create a protrusion. To do this, we select the ring created by the new sketch. Now we move on to the threaded hole. In this case, as in the third variant of the last video, you can simply make a hole. However, We also use reference elements to position the hole precisely. To start, select the tangent plane function under Construct. Then click on the large circular surface of the crank, which serves as the reference element. You can immediately see how the new plane is created tangentially to the selected surface. This alignment is based on the original geometry of the component. In the menu, you can adjust the angle of the plane to set the inclination angle of the subsequent drilling. In our case, we leave the angle at 0 degrees and confirm the plane. Now we place a sketch on the newly created tangent plane. With a right-click on the plane and the selection of Create Sketch, we get started. Place a point in the sketch and align it on the y-axis using the coincident constraint. Position it at a distance of 3 mm from the x-axis. Now we move on to the drilling itself. Select the Drill command and use the tangential plane as the orientation plane. To define the exact position, refer back to the point previously placed in the sketch. In the Hole menu, set the type to Thread and select the metric thread M4. For the limits of the drilling, choose the option 2 and mark the central circular surface of the component as the target. This way, you define exactly how far the tapping should go. Now we give the crank the final touch by rounding the edges. To do this, we use the fillet function. Select the 4 relevant edges one after the other and apply a fillet radius of 2 mm. In the next step, we use the command chamfer to create precise edge finishes. Mark the upper outer edge and the rear outer edge of the component for this. Enter a chamfer of 0.5 mm to achieve an even flattening at these points. Finally, we give the crank its characteristic material property. Go to the Materials menu and select Bronze. Congratulations! You have successfully designed the crank for our compressed air motor and learned how to trim geometry within a sketch. Look forward to more videos and exciting features that await you.